Hello, my name is Marcus, and I'm learning Rust by going through the Project Euler problems. Today we're on project number 12. So project 12, problem 12 is they give us the definition of a triangle number. It's where you're just adding the natural numbers before it and gives us a nice sequence. And then what we're looking for is finding the first triangle number with over 500 divisors. And they give us an example with 1 over 5 divisors, which is 28. So let's dive in. I've already stubbed out the problem. I did my cargo init, and we have it. So generating the triangle numbers will be pretty straightforward. Let's start with the counting the divisors. And we're going to receive a number. These might get big, so let's use a big number. And we're going to return a count, and that won't be quite so big. We can turn a number right now, and let's just stub out our test. So function test count divisors. And so we get a couple of examples above. We get count divisors. We don't need too many of these. Let's just do a small one. The number 3 has 2 divisors. The number, let's just do 15 has 4 divisors. And let's just do 28 has 6 divisors. All right, and so that's stubbed out. We can run it, and our test breaks as expected. We haven't done anything yet. So to count a divisor, it's pretty straightforward. We'll need a count, and then let's just loop through every single number. I start at 1 up to the number, and then let's see if I can type today, and then we just need to check if the number is divisible by I. That equals 0, then we have a divisor, right? So count equals count plus 1. Now, here we can return count, and we'll get an error. We'll see if you can spot what it is. A number is, for the for loop, we'll only go up to the 1 before that number. So for the number 4, this will only go to like 3 or so, right? It doesn't go all the way up. So it's not getting this last number. Each number is a divisor of itself. So if we do number plus 1, so we get the number itself. So if we're passing in, what's our example? If we're passing in 3 here, this will actually go 1, 2, and 3. We'll check each of those. And so now if I run it, our test pass. There's also a little bit of an optimization you can do here too, which I think we might need because we're going to be trying to find 500 divisors. So we're going to do these loops a lot. Is we only have to go up to the square root point, right? Because every divisor has a pair. So in this one, 1 and 28 is a pair, 2 and 14 is a pair, 4 and 7. So once we get to the middle point, once we get to the square root, or get beyond the square root of it, then we can break and we count by 2's. So in here, if I times I, the square root, or square, so we won't have to check that many. If that's bigger, we can break here. And then let's count by 2's then, right? So every one we find on the first half will be counted for 2 because we know there'll be a pair that it divides with. And then that, if we run the test, still passes, so we know that's all working. So now it'll just be a matter of generating our triangle numbers and seeing what we need. So let's, we're looking for the number of divisors. So we'll just start with 5. That's how many divisors it showed us. We want to get that 28 answer, right? You can do a loop here. And then let's start this will just be counting, right? Let's just start we'll start at 1, and then the loop will do I equals I plus 1. Probably can do a loop a couple different ways. We'll break out of this loop because we don't know how many it's going to take to find it. And then we need a start with a triangle number, right? So our triangle number, we'll start at 0, and then our triangle number would equal our triangle number plus I. So when we're 1, the triangle number will equal 1. And then the next time the number will be 2, then this will equal 3, then this will become 3, and 3 plus 3 will equal 6, and we'll build our number. We can try this out. We can print our numbers and just to verify what we're doing makes sense. And then here we'll just do if I is greater than 10. All right, we'll just do the first 10 because we have an input loop going. So if we run that, here's our first 10 triangle numbers: 1, 3, 6, 10, 15, 28, and 36, 45. Right, and that's what they show us here. We got up to 28 there. So we know this is working. We don't need that. And so in here, what we want to do is we want to count the number of divisors. So let's count the number of divisors will be our count. We'll call that function. And then we want to check if that number is greater than what we're looking for, which is up here, 5 divisors. Then if that's the case, we're done. We found what we're looking for. All right, and then here, let's just print them out. Do these this way. Found, and then we can print out some data on it. This will be the ith divisor. The triangle number will be equal to that with that many divisors, right? So it'll be I, and the triangle number, and then how many divisors it has will be ND. And then, so for 5, we should expect to see that the 7th number will be 28 with 6 divisors, right? And that's what we get. The 7th number is 28 with 6 divisors, so that answer would be 28. We can bump this up. Now we can look for 100 divisors and run it, and it finds it pretty quickly. You can bump it up. We'll do 400 just to get closer. Run it. So pretty quick. You saw a slight second. It took a second or so. Another optimization you can do, you can run cargo build release, and then that will create a optimized build. It'll be, the binary will be found in this target release directory. Then you can run that file, and it'll be a bit quicker. And that one's almost instantaneous. So there we have it. Number 12, pretty straightforward one. Couple of loops, and it was a good one. All right, thanks so much. Hope it helped. Cheers.